We've worked with David for probably a year and a half, 2 years through our affiliation with Mike Holmes. And so David's been a really instrumental, key person in educating us along with his partner Alan. And so I'm going to pass it over to him.
Yeah. Well, thanks everybody for coming out today for sure. As you guys know, I don't need to tell you inspectors anything, but the recent code changes in BC added the radon provision for the city of Abbotsford. So we're a building and environmental science firm, and we study only radon gas. We're the only firm of its kind in North America. There's certainly lots of building and environmental science firms, but they all have mold divisions and asbestos abatement divisions, and as a result, we've become sort of the leaders in North America in terms of radon awareness and coming up with creative radon mitigation solutions for new construction and existing construction alike. So I'll just give you a little bit of Radon 101. Does everybody here know where it comes from or have a bit of an idea? So radon, it's in the decay chain of uranium. And uranium's present in almost every single rock formation in the North American continent. So just to a greater or lesser degree. And unfortunately, the geology in this area here, going out into Hope and Mission, where a lot of the rock comes from, is quarried, is very high in uranium. So we expect to see high levels of radon out here. Uranium's got a great big long half-life. Half-life is about 4 billion years, so there's going to be lots of uranium around long after we're all gone. And as it decays, it becomes all the bad characters. It becomes polonium, it becomes thoron, and eventually radium, and then radon. And radon's got a short half-life of 3.82 days. And when we talk about mitigating radon, it's actually the radon progeny, or what used to be called the radon daughters, that we want to get rid of. So when radon decays, it releases 2 alpha particles, and those are radioactive. And they attach themselves to microscopic dust particles in the air. We breathe them in our lungs, and when it releases its energy in our lungs, it breaks our DNA chain. And our bodies are being bombarded all day long. The DNA chains are being broken and rebuilt. But every once in a while, that DNA chain gets rebuilt in the wrong order, and that's the origin of the cancer cell. So radon, it's the leading environmental cause of lung cancer, and the second leading cause after cigarette smoke. And if you happen to be a smoker and you live in a radon-rich environment, a typical smoker has a 1 in 20 chance of getting lung cancer. If that same smoker lives in a radon-rich environment above 600 becquerels, which isn't that high, their chances of getting lung cancer move to 1 in 3. So it's, we all know somebody that in our lives that smoked their entire life and hasn't got lung cancer. We certainly acknowledge, and the oncologists will tell us this, that certain people have a predisposition to getting cancer and others have a disposition to not getting it. So it's not to say that just because you're exposed to radon, you're going to get cancer, but statistically speaking, your odds are much, much higher. So today, in the building envelope, well, first I should talk about the action level, I guess. Health Canada has set the action level to mitigate at 200 becquerels per meter cubed. And what that measure is 1 becquerel per meter cubed is 1 radioactive decay per second in 1 cubic meter of air. So what does that look like? If you could see it with the naked eye, which you can't, it's colorless, odorless, and tasteless, it would look like a whole bunch of lightning flashes about this long. And I've got some folders here with my card in it. If you visit our website, there's an image of a radon chamber there where we've introduced radon and put dry ice in it so you can actually see the lightning flashes. So it would be kind of like sticking your head in, to be in a room with 200 becquerels per meter cubed, it would be like sticking your head in a beehive. There'd be that kind of activity going on. So it's really not good. The US has the action level set at 150 becquerels or 4 picocuries. They use a different measure, but that translates to 148 becquerels. And the World Health Organization sets the action level at 100, as does most of Europe. And they go on to say, but there's no level of exposure to radon that's safe. So one of the interesting changes that happened code-wise this spring is the Green Building Council, which manages the LEED buildings, the commercial buildings, they adopted the International Building Code, which now requires mandatory testing for LEED buildings, and the buildings have to be under 100 becquerels. So despite the fact that Canadian Health Canada guideline is 200, to get that LEED rating, you need to be under 100 becquerels. So that's where we'd kind of like to see the action level, is at 100, and understand that we'll get it as low as reasonably possible. So today, with the builders like Jonathan and Bob Deeks, the premium builders, they're building to that higher level of code as we talked about, and that's one of the things that led us to the relationship with the Homes Group, is we like that, you know, high quality, that stepped up code, if you will. But the result of that is super airtight homes, right? So these guys, you know, guys like Jonathan, you know, they've got a slogan going now where they'll build it tight but ventilate it right. And it's super key, the ventilation, because when you build a tight home, and you know, this home, Jonathan and I were talking earlier, the average builder home now has what, about two and a half air changes per hour when they're done. This home here will be built to 0.4 or 0.6 air changes per hour. So what that means is you're essentially living in a plastic bag, if you will. So you've got to have that ventilation. And we really validated that with Dr. Aaron Godarzi, who's a research oncologist at the University of Calgary, who's been studying radon gas for the last 6 or 7 years. And if you Google him, he's done a TED Talk on it, which will give you a lot of the genealogy and how the cancer cell works. But at the end of the day, we're working with him to test 40,000 homes. We've got results on about 10,000 homes right now. And of the homes with elevated levels, 78% of them were built in the last 12 years. So that validates what we kind of already knew. In tightening that envelope, we're trapping more soil gases. And in doing so, the radon levels are higher. So in this house here, we're using a product, excuse me for a second, called Radon Law, which is an engineered membrane to block radon. So the way this product works is it's a 7-layer laminated EVOH product. In the middle, there's that EVOH layer sandwiched between 3 layers on the bottom and 3 layers on top. And the reason we use EVOH is it's positively charged. So when those radon progeny are trying to move from the soil or below the slab into the home, they're attracted to the positively charged EVOH layer and they don't go through it. So this has got the lowest radon diffusion coefficient, which is the measure of radon that passes through a membrane of any product on the marketplace. The poly that's in the code, you can tape it, you can seal it to the best of your ability, but it does not block radon. Radon diffuses right through poly. And we spent, 3 years and untold amounts of money with the National Research Council in Ottawa testing this. We actually built a chamber, a radon chamber to test it. So it's got the CCMC approval. It replaces the poly in the code and functions as the vapor barrier as well. And we'll go down in the pit after and you can see the installation process. There's an overlapping, and you tape the seams and tape the perimeter, and then tape your penetrations and pour your slab. So we didn't use it on this particular home because of the site grade conditions, and there was a lot of backfilling required, but I think the rest of the homes will probably put this in. This is called Radon Guard. So this is code approved to replace the gravel layer under the slab. So it creates, as you can see, it gets installed like this. It creates an air plenum from which we can easily vent all the soil gases, not just radon. And it allows us to depressurize below the slab, because that's really what we're doing with the vent pipe that goes outside in the code, is we're trying to create a pressure under the slab that's negative relative to the pressure in the house. Because as soon as we get there, physics is our best friend, because things will not move from an area of low pressure into an area of high pressure. It just doesn't work like that. And in developing this product, we make it in a range of thicknesses for different R values. So if you're putting hydronic heat in, it's a great product. You're insulating the slab anyhow. And this air plenum also creates a thermal bridge between the ground and the slab, which, we've created all these thermal bridges in the house now, right? So we're eliminating them rather, and so this creates the same under the slab, okay? Does anybody have any questions?
So just a couple of questions. Maybe just address existing homes, how you might mitigate radon.
Sure.
And then maybe talk about your little testing device.
Yep, yep. In the front of my briefcase, there's a test device in one of the zippers there. Yeah, so existing homes, you know, can be a little bit of a challenge. The normal route in North America is called sub-slab depressurization. So if we tested a home, and incidentally, the only time we can accurately test the home is once it's finished, built, and occupied. We would go into a house that had tested high, that was an existing build. We'd core a hole in the slab in the basement, a 5-inch hole, dig out a little bit of the fill or gravel underneath, and then we'd put a vacuum test on that and drill some communication holes across the slab and put suction on that to see what kind of pressure field extension we get. And assuming that that works well, with one vent pipe, we'd install an inline radon fan, vent that to the outside, and that fan would run 24/7, and it would depressurize the slab so that we get that favorable pressure differential that I spoke about, and that eliminates the radon. If by some reason that didn't work, then we'd have to go to ventilation and use an HRV. And we've developed a product that's called a Radostat. It's an indoor air quality sensor controller that constantly measures the radon levels, connects to the terminal strip on the HRV on the high-speed override contacts. When it detects a peak of radon, it's going to turn on the HRV and change the air. And when we install that Radostat, we rebalance the HRV to a slightly positive. We bring in about 10% more air than we're taking out, and that gives us that favorable pressure differential that we're looking for just by using the HRV to positively pressurize the house. So to test the home, the most accurate testing, and you know, I shouldn't say most accurate because there's laboratory grade equipment that's hundreds of thousands of dollars that's more accurate, but most testing is done residentially and commercially with this device here. It's called an Alpha Track, and it's a 90-day to 365-day test. And the reason we want that is that the radon levels will change hourly in the home. If we had a big windstorm today, it pressurizes the soil and drives lots of radon out. So you see on a windy day, radon levels go up. So we want that minimum 90 days of reads. And basically you open this pack and the test begins. This is shrink wrapped, as you can see, out of the factory with a little bit of nitrogen in it. And that keeps any radon from diffusing into it. As soon as we open the bag, the air diffuses into this. After 90 days, you're going to send it back to the lab. We read it, and then we calculate the total exposure. And then you've told us by registering the device online how long it was in the field for. And then we calculate the average radon level, and you get the results electronically.
Can you just address radon in water for me, please?
Sure, yes. So radon, for many years, we started this company 12 years ago and spent the first 7 years and millions of dollars doing research and development on radon. And one of the things that we discovered was the old science had always been that the only fear for radon in water, because it is highly soluble in water, is when it enters the home and it's aerated. So if you're taking a shower or washing the dishes, flushing the toilet, doing laundry, it breaks that plenum and releases the radon gas back into the air, and we breathe it in. And about 7 years ago, we said, you know, that doesn't make sense. There's got to be health impacts of ingesting radon-contaminated water. And sure enough, you know, another 7 years down the road or 6 years down the road, there's been lots of discoveries linking the ingestion of radon-contaminated water to stomach cancer, colon cancer. There's a study going on at the University of Phoenix right now looking at linking the ingestion of radon-contaminated water to early onset dementia and Alzheimer's. So we developed a system called Airwell, which is a down-the-well system to aerate the standing water column in the well and reduce the radon levels in well water by 99%. City water tends not to have radon because By the time the city water reaches your house, it's been aerated several times as part of the filtration process by the municipalities. But certainly anybody on a well, generally speaking, if you have a home on a well and the air tests high for radon, you will have some level of radon in that well water. It's very rare that we see high levels in the air and don't see any radon in the water. The U.S. is light years ahead of Canada in terms of radon awareness. I was telling Jonathan this morning, there's 33 states in the U.S. now where when you sell your home, you have to test and disclose the radon levels. And if they're high, either you have to mitigate or money goes into escrow for the new owner to mitigate. And in the U.S., the states, they're forcing people to test their wells now. All of the New England states, it's mandatory you test your well water once a year, including for radon. And the state gets a copy of the results. If it comes back above the U.S. action level, the state will come to you and say either drill a new well or mitigate the radon in water. They're that concerned about it. So, you know, Health Canada is slowly catching on. You know, we lobby with them and work with them in partnerships and awareness programs, and it will come to Canada, but it's not going to come in the very near future, I don't think.
Great.